how's it going, everybody? Brad the Guitologist here. In this video, we're going to look at this old signal generator. This is a, I don't know, is this RTTA? Is that the make? I don't know. And then a model K-7 signal generator. You can see here the dial indicator is warped and pretty badly, actually. So we may try to do something about that to maybe try to flatten and straighten that back out. For now, it does actually work. I mean, it would indicate roughly where, where you're setting things. I do not know the state of this thing. It looks like this can generate audio frequencies and radio frequencies. But it looks like you can actually run both at the same time. You can do radio frequency and audio frequency separately and simultaneously, perhaps. Okay, no, I see. Okay, so you have different bands here. If you select a band, that gets you up to what, 480 hertz, and then it picks up from there and goes up. There would be like your standard 1K. If you set it to B and 1K, that's your 1K. There's 1400. If you go to C, it starts to get up above that. Looks like the highest it goes is about 68K on the audio frequencies. I'm not sure how the RF. I'm guessing maybe those same frequencies overlap for RF. I don't know. But it's missing a handle. It's kind of in really rough shape. It does have a power cord that appears to be in pretty decent shape, though. It's not cracked or anything. So actually, I'm tempted to just plug the thing in and see what it does, but I don't want to start a fire in my house. So let's actually go ahead and just pop the front off and make sure nothing looks like it's shorted or obviously bad or anything before we just go and plug this thing in. Yeah, these are the dumbest little screws. Wow. All right. Okay. Should be ready to pop her open. There ain't no telling what we're gonna find inside this thing. I mean, it's been sealed, so it should be, and it is. It's clean. Full of paper capacitors. Full of paper capacitors. Paper and wax capacitors. There's a Bendix. Paper and wax. That's paper. These are all paper and wax. Zenith. Wow. Zenith? That's interesting. We do have a little bit of a mix of brands here. We've got these are mica molds over here. These paper and wax caps. That's mica mold. That's mica mold brand. Bendix. Like I said, another Bendix and a Bendix. So we've got 3 Bendix, 3 Zenith, 2 mica molds, and then we've got this big guy right here, which I cannot read. Let's see a code on it. 472452. So I would say this is probably, what would you say, 1964 or 54? Probably 54. The reason I say 54 is because it has octal tubes, and if it was 64, I would expect to see miniatures. So what we got here is a 6x5 rectifier, and we have a 6SN7 tube over here, and that's a Jan Tungsol. Man, that would be a good tube for an amplifier, probably. We'll get our oscilloscope set up. Let me get something to plug into here, and we'll see what happens when we plug it in. Let's see if we get anything on the scope. Now, if ever you're trying to start up a piece of equipment like this, and you're wanting to try to preserve the capacitors, if you don't want to have to worry about doing anything with the capacitors, definitely don't just shock it to life like I'm about to do, because I'm about to flip the switch on something that's been, God knows, what sort of conditions this thing has been through. And by the look of it, nothing favorable. I mean, look at that. And it probably has not seen electricity for maybe 40 years, you know, 35, 40 years is my guess. So, you know, if you're wanting to avoid issues, don't do what I'm doing here. And there's going to be some among you who are like, why is he just doing that? That's so stupid, you know. Well, because it's entertainment. That's why. All right, we're going to power on the scope. And we should start seeing a line, hopefully, some stage. Yep, there's a line right there. So we definitely have something going on. Let's see if I can up that contrast on that line. There we go. Well, let's see what happens. It's not on yet, but let's see what happens when we turn it on. I'm going to actually put it on. I'm going to assume that we can hit a 1K target here. So I'll put it on B and put it over here to about 1K. All right, then we'll go ahead and fire it up. Well, actually, let's get you off of here before I fire it up so we can look at tubes and all that good stuff. All right, 3, 2, 1. There we go. And do we have any glow? Yes, we do. We have glow in that tube. What about this one? You see any glow in this tube? I don't see any. I do not see any glow in that tube. Let's pull this tube. It could be a bad 6S and 7, or it could just be that the capacitors are so bad we're not getting anything. Plugged it back in and I don't see anything. So I'm assuming for the moment we probably need a 6S and 7. There's no indicator light on the front of this thing either, which would really suck if you couldn't see, you know, if you couldn't see any of the filaments. I'm not even seeing filament glow now on the 6X5. There's no glow on it. I thought I saw filament glow earlier on the 6X5 and now I'm seeing nothing. Okay, I'm seeing it when I start up on RF. Okay. So the switch, this is switching on. Okay, I'm getting glow now. Okay, now we're getting some output too. It looks like maybe both of those have to be on. Wow, that's a funky looking, look at that wave though. That looks terrible. These controls are a little bit touchy on this. Well, there's definitely some volume control, and there's an actual output here. So that's a positive. We've got something, obviously. I'm going to switch down to A. I don't know. It seems kind of intermittent for one. I'm gonna move this. Whoa! Okay, I got a little bit of a shock there. I got a little bit of a shock. I'm gonna try not to do that again, if I can keep from it. Okay. Well, that's definitely a higher frequency. Yeah, see there? You can see that that's a much, much higher frequency, the RF. See there? I don't know, maybe you can't see that, I don't know. Let's see. See if I can focus that a little bit. Yeah, see, this is touchy. All these controls need to be cleaned. Like I said, this is a piece of gear I found on the shelf that I'd forgotten that I had. Yeah, you can just kind of see all the interference. There's just a lot of interference and stuff going on here. It's not really ideal. Let me see if we can turn this up a bit, get some more amplitude. Yeah, lots of noise there. You can see it, obviously, but it's just a really noisy signal because none of this is really shielded. I don't have the right stuff here, and plus, I mean, who knows what state this signal gen is in. But like I said, it is working to a degree. I'm going to undo this again, hopefully without shocking myself. I think what I did earlier was I bridged from here to there. I want to try not to do that. Okay. Yeah, so we got some kind of half wave stuff going on with this. It's not, and also it's not even changing. So basically it's just noise coming out of the audio output side. And my guess is these tubes are probably taking a beating right now just because of how bad these caps are. Yeah, this is a candidate for restoration though. This probably would work. It's a very simple signal generator. It'll just generate sine waves only by the look of it, all the way up into RF ranges. It's interesting though that you have to turn on. It looks like the RF has to be turned on in order for the unit to be on, which I guess isn't the hugest of deals, but it's just funny that this has an on-off too, and it doesn't appear to work. We'll look at that. I'll see if I can find some documentation on this thing. We'll recap it, maybe if nothing else. So yeah, if you're watching this, that means I probably did decide to go ahead and recap this thing. And if you're not watching it, I guess, well, you're not watching it, and I'm talking to nobody. Okay, so probably what's going to be a recent video for you, I did this inline capacitor tester by ICO. This is ICO 955, and this is a good real world testing scenario where we can test all these capacitors in circuit. Now at the moment I've got everything set, and I'm reading what should be, I think this is supposed to be a 60 microfarad. It sure looks like 60. It's either 60 or 80. It's kind of scratched off, unfortunately. But I'm going to the correct lead and going to ground around this capacitor. And right now, instead of 60 or 80 microfarad, I'm actually reading about 0.5 microfarad. And also it's extremely leaky. We can see here, if we get this down, you can see it's yeah, it's just exceptionally leaky, and I mean almost shorted. It's leaky to the point where it's really almost shorted. It's not shorted, but it's almost, and not measuring anywhere close to what it's supposed to be measuring. So this capacitor would have to be reformed in order to. This thing is from 1954. Obviously, I did not expect, you know, the paper and wax electrolytic capacitor to be good from 1954. So, you know, that doesn't surprise me. Going to the other capacitor that's in this can. Come over here to this lead, this green one, and this one's definitely supposed to be 50 microfarad. And we'll see where it reads. We'll set this thing back up to infinite. And it's really not liking, it's not liking this. It's not liking this really at all. I'm turning this down, the RC balance, and it's yeah, once again, that's all the way as low as it can go, that RC balance. It's almost a dead short. And actually I can test that. It's not testing shorted. It's not shorted. It's not right. I'm going to test it with my fluke just for giggles here. I want to test around it. I want to see what the resistance is at this point. Measuring about 5 megs. Well, there's 500K. Now it's bumped up to 5 megs. Let's see what the microfarad measurement is. 25 microfarad times 5 megs, so that's going to be 5,000. So 125. So I mean that shouldn't be measuring that, but that's not a good capacitor. Let's try one of these other ones over here. This one's supposed to be 0.002, so that's a very small capacitor. I don't know if we can't really measure that in circuit. This one will only do 0.1 and up. That's a 0.02. Maybe this one. Here's a 0.1. There's an old spider. Dead one. Okay, the Fluke needs batteries. Okay, it's sort of measuring correct on the microfarads on this one, but it is really, really leaky, this capacitor. Okay, I have this thing totally recapped now, and this is only really outputting sort of a sawtooth wave. It's not pretty. It's not a sine wave, so it kind of slopes up and then drops straight off. I think that's what this thing is supposed to output by design, and you can't adjust the audio frequency either. You can adjust the RF frequency, but not the audio. The only thing this really seems to do is it just seems to align it somewhat and focus the wave. It's not really, and you can also increase the amplitude, but that's about all you can really do with this thing. You can't see. I can actually pretty it up quite a bit by increasing the amplitude over here and then dropping it down here. But yeah, it is what it is. It's a very cheap, old school device, and it's not really meant to do very much. And I think the radio frequency, it will do more frequencies, but for the audio output, this is all it does. All right, guys, well, that's going to do it for this one. I know it's maybe slightly disappointing. I did do some research after cleaning this thing up. I did give it a little bit of a wash, and I was able to actually straighten that dial out just a little bit. But, other than that, this thing probably won't see a whole lot of use, just simply because it does have this sort of sawtooth pattern instead of a more traditional sine wave pattern. I'm thinking they did that maybe because of parts count. RTTA was a radio and television technical association that existed in the 1950s. So, post-war Europe, while they had a lot of austerity, countries like, Germany and France and Great Britain, because they were destroyed by the war, in the U.S. we had a lot of manufacturing, a lot of, the returning soldiers who did come back after the war ended up getting jobs, good jobs in factories or started factories. And, all the American homes were being filled by all this electronic stuff. So naturally, you needed technicians out there to service all this stuff. And the RTTA was one of those places where you could essentially get a correspondence course in radio and television repair. And they, would also provide you with the stuff that you would need, like the signal generators and the oscilloscopes and this and that, and it was all part of kind of a package deal. And most of these, there were several, actually, it appears, competing companies, and they would all advertise in these old magazines, electronics trade papers and stuff like that. They all seem to be located in cities like, you know, New York, Chicago, Philadelphia, places in New Jersey and stuff like that, places where they had a lot of the manufacturing of the equipment itself. So that gives you a little bit of a history of this thing. It probably won't see a whole lot of use, but it, you know, technically it could be on a working bench. It just wouldn't be that flexible of a piece of gear, but it does produce a signal, and it does produce a wave that's, although it's a sawtooth wave, you would at least be able to diagnose problems with certain pieces of gear. And it also will put out an RF signal, which will allow you to diagnose problems with radios as well. So that will do it for this video. I hope you've enjoyed it. If you have, hit subscribe, and for now, we'll see y'all later.